This lesson will focus on the relationships that exist in a second type of special right triangle, known as the 30, 60, 90 right triangle. And although you're more than welcome to go ahead and read the writing, I'm going to go ahead and just jump right in because I think it might be easier to show you this visually as opposed to reading the written words in the language. I'm going to go ahead and I'm going to begin by looking at an equilateral triangle. And I'm going to choose to let each side of my equilateral triangle be represented by 2x. The reason that I picked 2x is that I'm going to next go in and draw in the perpendicular bisector, you might call it the angle bisector, the median. For the equilateral triangle, all three of these segments are exactly the same thing. So in this next step over here, I'm going to go draw in again that angle bisector, the perpendicular bisector, the median. And in doing so, it'll split the base of that triangle into two pieces, each of whom measures x. And that's why I chose 2x. This way I don't have to deal with fractions. I'm now going to go ahead and I'm going to isolate that right triangle. So I'm essentially going to take half of my equilateral triangle. And the first thing I want you to notice is the relationship between the length of this leg that's opposite the 30-degree angle, which I'm going to call the shorter leg, and the hypotenuse. Notice that the length of the hypotenuse is double the length of that shorter leg. So in other words, in going from the shorter leg of x to find the length of the hypotenuse, we would also always multiply the length of that shorter leg times 2. But what about the relationship that lives or exists between the shorter leg and the longer leg? For lack of something better, I'm going to call the longer leg A. And in order to determine that relationship, I'm going to go back to my trusty Pythagorean theorem. My a squared plus b squared equals c squared. And again, I'm working in this right triangle where one of the angles measures 30, one of the angles measures 60. The hypotenuse is represented by 2x, and the length of the shorter leg is represented by x. So I've got an a squared plus an x squared is equal to the length of the hypotenuse, 2x squared. Keep in mind that when you square the expression 2x, you need to square both the 2 and the x. So the right side of that equation, when squared, will become 4x squared. Subtracting an x squared away from both sides yields the equation a squared is equal to 3x squared. Taking the square root so that we can solve for a, we find that a is equal to the square root of 3x squared, or that a is equal to x root 3. So the length of this longer leg is always going to be the length of the shorter leg, x, multiplied by square root of 3. I'm going to backtrack just a little bit, and I'm going to say that I know that the shorter leg is going to be opposite the smaller 30-degree angle. That's how I know that x represents the shorter leg in this right triangle. The longer leg is going to be the leg opposite the larger or 60-degree angle. And the hypotenuse, of course, is going to be the side opposite or across from the right angle. So the key ideas or relationships that you need to be aware of for this 30, 60, 90 right triangle is that number one, the hypotenuse is always double the length of the shorter leg. And that number two, the length of the longer leg, is always root 3 times the length of the shorter leg. Or in other words, I like to say these three sides are in the ratio 1 to square root of 3 to 2. As you can tell, this is a little more complicated than our work with the isosceles right triangle, due to the fact that instead of two different side lengths that we had with the isosceles right triangle, now for the 30, 60, 90 right triangle, all three of our sides are different lengths. Let's go ahead and jump in. Just as a reminder, when it says exact answers only, they're really asking us to put these in simplest radical form. So in other words, no rounded or approximate answers. All right, so in looking at the first picture here, we've got this 30, 60, 90 right triangle. I know it's 30, 60, 90 because the right angle measures 90. This first acute angle measures 30, which means the second acute angle in that triangle has to measure 60. The hypotenuse is going to be y. I know that's the hypotenuse because it's opposite the right angle. The shorter leg, remember, is going to be opposite the smaller angle. The longer leg is going to be opposite the 60-degree angle. I'm going to work backwards from the longer leg, and I'm going to find the length of the shorter leg first, because once I know the length of the shorter leg, I can just multiply it times 2 or double it to find the length of the hypotenuse. So I know that in going from the length of the shorter leg to the length of the longer leg, I multiplied by a square root of 3. So in working backwards now, I'm going to start with the length of that longer leg, and to undo the multiplying by root 3, I'm going to divide by root 3, making x, or the length of the shorter leg, 5 over root 3. And if I then want to go ahead and use that to find the hypotenuse, I would take that length and I would multiply it times 2. So I've got, in essence, 5 over root 3 times 2, or times the fraction 2 over 1. And a short little reminder about multiplying fractions, recall that when you multiply fractions, you multiply their numerators and multiply their denominators, making the length of our hypotenuse 10 over the square root of 3. Notice that in this example, I went and I found the length of the short leg first. That's going to be a great strategy for you to employ, because once you know the length of the shorter leg, you can find the length of anything else that you want to. All right, and looking at the next problem, letter B, I've got y, which is the hypotenuse. I've got x, which is the short leg, opposite the 30 or smaller acute angle. And I've got root 15, which represents the length of the longer leg, opposite the larger acute angle of 60. So once again, they've given me the length of this longer leg, and I know that I get from the length of the shorter leg to the length of the longer leg by multiplying times the square root of 3. So to undo that multiplying by square root of 3, I'm going to simply divide by it, making the length of the shorter leg, root 15, divided by root 3, or square root of 5. And then to go from the length of the shorter leg to the hypotenuse, I simply take the length of the shorter leg and I double it, or I multiply it times 2, making the length of our hypotenuse 2 times the square root of 5. All right, which brings me to the last example, and this one looks fun. I've got a couple of different triangles here built into the same exact picture. So I'm going to go ahead, because they've given me this measurement of 4 square roots of 2, I'm going to start here in this red triangle, which I notice happens to be an isosceles right triangle. One of the acute angles is 45, making this other acute angle 45. So I know that these two legs have to be the same. I remember my rule for the isosceles right triangle is that I multiply the length of either leg times the square root of 2 to get the length of the hypotenuse. So x times the square root of 2 gives me 4 square roots of 2. So to go backwards, I would take that 4 square roots of 2 and divide it by square root of 2, making the length of that leg in the isosceles triangle, or the leg in the red triangle, 4. The other thing that I happen to notice is that that leg, or that leg in that isosceles triangle, also happens to be the shorter of my two legs in the 30, 60, 90 right triangle, or in the purple triangle. So in this purple triangle, I've got this acute angle that measures 60, making my longer leg y. I've got the right angle making z my hypotenuse, and this acute angle is 30 degrees, making that length of 4 the shorter of my two legs. Once I have the length of the shorter of my two legs to get the length of the hypotenuse, I multiply it, making z 8. And once I know the length of that shorter leg, to find the length of the longer leg, I multiply times square root of 3, making the value of y 4 square roots of 3. I would have to say that one of the most important things about this video is that you really have to know these rules well. You have to know that for the 45, 45, 90 right triangle, the ratio is that 1 to 1 to square root of 2 ratio, or that in other words, the length of the hypotenuse is equal to the length of the leg multiplied times square root of 2. And for the 30, 60, 90 right triangle, you have to remember that ratio of 1 to square root of 3 to 2. Or that in other words, the length of the longer leg is equal to root 3 times the length of the shorter leg, and that the length of the hypotenuse is equal to double the length of the shorter leg. And those would be, I have to memorize those rules. Make sure as you're working with these, you keep your triangle straight. If you're working in the isosceles right triangle, that's the rule that you want to use. And as you're working in the 30, 60, 90 right triangle, you want to make sure you use the rules that go along with that particular triangle. All right. So as always, thank you for your gift of your time and watching the video. Take a few minutes, summarize the key ideas and words that are important and meaningful to you. See if you can apply your newfound knowledge to solve the problems on the following page.